In this next problem, we're going to have the titration between a strong acid and a strong base. So in the reaction between a strong acid and a strong base, usually we look at the reaction between H plus and OH minus to produce water. So in this case, all we need to do is determine which of the species is present in excess. Okay, so if we're going to have a problem like this one, so we need to determine the number of moles of HCl. So we can put here 30 ml divided by 1,000 ml per liter, then multiply it with 0.5 moles per liter. Okay, so the number of moles of your H plus here is just equals to 1.5 times 10 to the negative 3 moles. Okay, now in the first problem, since there's no KOH added, so everything here just depends on the concentration. Okay, the negative log concentration of your HCl. So if you're going to get the negative log of 0.05, your answer here would just be equals to 1.30. Okay, now in part B, you're now adding here 5 ml of your 1 molar KOH. So if you're going to look at the numbers of moles of the hydroxide ion here, so it's just 5 ml divided by 1,000 ml per liter, and then you multiply it with 0.1. So the amount, the number of moles that you have here would be equals to 5 times 10 to the negative 4. So between the 1.5 times 10 to the negative 3 moles of H plus and 5.4 times 10 to the negative 4 OH minus, so we can subtract that, giving you an excess of 1.0 times 10 to the negative 3 moles of H plus. Okay, so you get that number of moles of H plus, and then you divide it with the total volume, which in this case is 30 plus 5 ml divided by 1,000 ml per liter. Okay, so doing this thing, you're going to get a concentration of around 0.029. And if you're going to get the negative log of 0.029, that would be equals around 1.5. Okay. So you can write 1.5, or you can put the next number there around 1.54. Okay. So that's the pH after you add 5 ml. Now for C, what happened for C is you have the same number of moles as 1.5 times 10 to the negative 3. And since this is a titration between strong acid and strong base, so most likely the pH is just around 7.0. You have the same amount of moles for both the strong acids and strong base. Now, for the D, okay, so this is where you're going to get 16 ml divided by 1,000 ml per liter, and you're going to multiply it with 0.1 moles per liter. And you're going to get your 1.6 times 10 to the negative 3 moles. Now, you can subtract it with the moles of your H plus. So in this case, it's the hydroxide now that is present in excess. So that is 1.0 times 1.0 times 10 to the -4 moles of your hydroxide ion. And then you're going to divide it with the total volume, which is just what, 30 ml plus 16 ml divided by 1,000 ml per liter. So if you're going to have the 1 exponent -4 divided by 46 divided by 1,000, you're going to get, okay, so that's 30 plus 16, so that's 46. So you're going to get a concentration of around 2.17 times 10 to the -3. So this is the concentration of your hydroxide. So you get the negative log of that, POH. So that will give you 2.66. And to get the pH, so 14 minus 2.66, so that is equals to 11.34. So as you could see, from 1.3 to 1.54 to 7 until 11.34.